So in question 3, we are told that the figure below shows the displacement time graph for a wave. So on the y-axis, we've got displacement, and along the x-axis, we've got time. So let's draw a sketch of this graph because we might need it later. So that is time in seconds. And this one here is displacement in meters. We are also told that the time from this point all the way to this point, the time is 0.002 seconds. So let's proceed with the questions. In part A, we are asked, how many complete cycles can we see? A complete cycle is from this point all the way to this point. So that is a complete cycle. Another one is this one. So those are 2. And we've got 3 and we've got 4. So in part A, we say there are 4 complete cycles. There are 4 complete cycles. 1, 2, 3, 4. Now let's look at part B. Part B, we are asked, what is the frequency of the waveform shown? In order to determine frequency, we must remember that frequency is the number of cycles that have been made divided by the time taken to make those cycles. So there are 4 cycles, and the time taken to make those cycles was 0.002, and we can get the frequency from this expression. So the only thing we need to remember here is that frequency is the number of cycles made in unit time, and we can get it by dividing the number of cycles that we can see divided by the time taken to make those 4 cycles. So in order to simplify this, because we are dividing by a decimal number, we'll multiply by 1,000 in order to make the denominator to be a simple number, and we do the same for the numerator. So we also multiply here by 1,000. So this is going to give us 4,000 divided by 2, and that gives us 2,000 Hz. And that is the frequency of this oscillation. Now, is there another way that we can use to get the frequency? Of course there is. This time here, the time taken to make one cycle is referred to as periodic time. So we've got the first periodic time, we've got another one, we've got the third periodic time, T, and we've got the fourth periodic time, T. So if we do T plus T plus T plus T 4 times, we are going to get 0.02 seconds. So we will do T times 4, it will give us 0.02 0.002. And in order to get t, we'll get 0.002 divided by 4, and that will give us 0.0005 seconds. And then we can get the frequency by using this equation. Frequency is equal to 1 over periodic time, and this will be 1 over 0.0005. And over here we can multiply by the lower number. We can multiply by 1, 2, 3, 4, 10,000 to make it a simple number, and we do the same for the numerator, 10,000, and we find that this one will be 10,000 divided by 5, and of course that one will give us 2,000 Hz. So this is the second method that we can use to calculate the frequency. I'm giving you this second alternative because in an examination situation, you find that when you read the question, the solution to that particular question will depend on what you know at that moment. You may immediately remember that maybe to calculate the frequency, you just need to divide the number of cycles by the time given, and that information, you can see it in the question, so there will be no problem there. But another student may remember this particular expression here, that frequency is equal to 1 over periodic time, and does not remember anything like this. So you see, there is that particular problem. So, knowing more than one method of how to solve a question is important, because it will make your problem solving much easier, because you will remember one of those methods. Now let's look at part C. In part C, we are told, draw a diagram to show the waveform of a wave whose frequency is twice and whose amplitude is half the one shown in the diagram. Now, how do we proceed? Let me use a different color for this part. Now, this is amplitude. So I'm going to divide that amplitude by 2, and I draw a dotted line here, because it's the one which will guide me on what I'm going to draw. And of course, this other line here shows half the amplitude. So from here to here may be 2 centimeters, but from here to here is 1. So the wave that I'm going to draw will have a maximum amplitude up to the dotted line. The next thing we are told is that this new wave has twice the frequency. That means its periodic time is half this one. So wherever we have half a period of the previous wave, in the new wave, in half, it's going to take a complete wave like this. You can see from here to here it was half a period. Now it is the time for a complete wave, because the new wave must have twice the frequency, and therefore its periodic time must be equal to half that of the previous one. So I'll do the same for this other half cycle. This one, a complete cycle for half of the previous wave, like that, and finally here. So you'll find that this new wave has twice the frequency because it has made 8 oscillations in the same time interval. Now let's look at part D. In part D, we are told that a radio wave has a frequency of 3 megahertz and travels with a velocity of 3 times 10 raised to power 8 meters per second. So let's see how we can solve this question. So let's erase this because we need a little bit more space here. Just need that much space. That will be enough. So in this part, we are told that the frequency is 3 megahertz. 1 megahertz, we have already been shown that 1 megahertz is 10 raised to power 6 hertz. That is 1 million hertz. So 3 megahertz will be 3 times 10 raised to power 6 hertz. The other piece of information we are given is the speed of the wave, which is 3 by 10 raised to power 8 meters per second. This is the speed of all electromagnetic waves. Now we are required to calculate the wavelength of these waves. So wavelength, the moment you are given the frequency and the speed, you can get the wavelength by dividing the speed by the frequency. It is just as simple as that. So 3 by 10 raised to power 8 meters per second divide by 3 by 10 raised to power 6 hertz or per second. You remember we have already learned that the other unit for frequency is per second, so that these ones can cancel out and you're left with meters. 3 and 3 will cancel out to give you 1 by 10 raised to power. Now when 10 raised to power 6 comes to be the numerator, we're going to have, 10 raised to power 8 is there. The other one is 10 raised to power minus 6. When this denominator becomes a numerator, the power changes. The sign of the power changes. For example, this one is 10 raised to positive 6. Of course, we usually don't write positive in front of the number when the number is positive. So every number which does not have a negative is assumed to be positive. But again, we don't write that positive. So, but when it acquires a negative sign, we have to indicate it. So this is going to be equal to 1 times 10 raised to power. Now, here we are going to have 8 minus 6. We add these powers. It is like 8 plus minus 6, which will be 10 raised to minus 2. This one will be 1 by 10 raised to power 2 meters. Or 100 meters. And this question is just as simple as that.